Hold a piece of copper in your hand right now. Go ahead. Feel that? Cool. Solid. Dead. Nothing's happening, right? Wrong. You're holding something so violently alive, so utterly chaotic, that if you could see what's really going on inside, you'd drop it in terror. Inside that innocent metal, there's a war. A silent, invisible, never-ending war between forces so incomprehensibly powerful they could tear planets apart. And here's what'll keep you up tonight. Nobody, not Einstein, not Feynman, not anyone, knows why it's happening. We only know one rule. Like repels, like unlike attracts. For words. That's it. From this single, maddeningly simple principle, you can rebuild everything. Electricity, chemistry, light, life itself. But the principle? We have absolutely no idea why it exists. Let me show you the war. Inside your copper, inside everything, are atoms. Forget those clean textbook diagrams. Picture instead a packed nightclub at 3 a.m. At the center, protons huddle together in a tight, aggressive cluster. Circling them at distances vast beyond comprehension on their scale are electrons, restless, kinetic, searching. The protons carry something we label positive charge. The electrons are negative, and they obey that rule with religious fanaticism. Proton and electron, they're drawn to each other with a hunger that never dims. 2 protons, 2 electrons, they'll shove each other away with equal, opposite violence. Here's the first crack in reality. We have no idea what charge actually is. None. We've measured it, named it, tamed it, built civilization on top of it. But the essential nature of charge, the why beneath the what, remains nature's most closely guarded secret. It's not a mystery we're solving. It's an axiom, a rule written into the fabric of existence with no author's signature. Back to our nightclub. In some materials, rubber, glass, your phone case, every electron is chained to its atom like a prisoner to a wall. They can feel the pull toward movement, can sense the chaos beyond, but they cannot leave. These materials are insulators, prisons for charge. But copper? Copper is different. In copper, the outermost electrons are free, untethered. They drift like ghosts in a metallic landscape, belonging to no single atom, wandering aimlessly through the entire structure. This sea of nomadic particles makes copper a conductor. When you wrap copper in rubber, you're creating something brilliant, a highway of wanderers surrounded by immovable prisoners. Electricity flows along the inside, but can't escape through the outside. That's the entire trick behind every wire in your walls. Simple, elegant, powerful. But wandering isn't flowing. For these electrons to become electricity, they need a reason to move together. They need a push. Imagine a level pipe full of water. The water sits motionless. Now tilt the pipe. Raise one end. Suddenly, water flows, driven by the difference in height, the pressure gradient. That difference is the hydraulic version of what we call voltage. Voltage is electrical tilt, electrical pressure, electrical desperation. A battery creates this desperation through chemistry. It forcefully pumps electrons to one terminal, the negative end, creating a crowd. It simultaneously drains them from the other terminal, the positive end, creating a void, a scarcity. This imbalance isn't stable. It's not meant to be. It's a wound in the electrical field, desperate to heal. Connect the 2 terminals with a wire, and you've given that wound a path to close. The crowded electrons stampede toward the empty space. That collective stampede, that's electric current. But the journey isn't smooth. As electrons drift through the wire, they collide with the fixed atoms in their path. Each collision transfers energy, making those atoms vibrate faster. And what do we call faster atomic vibration? Heat. This is why a wire carrying current gets warm. This is resistance, the atomic friction of an electron sea flowing through metallic lattice. A thin wire creates more resistance than a thick one, just like it's harder to suck a milkshake through a coffee stirrer than a smoothie straw. Now here's where it gets beautiful. Take a wire with extremely high resistance, like tungsten filament in an old incandescent bulb. Force current through it. The collisions become so violent that the atoms don't just vibrate, they scream. They glow, white hot, throwing off light in every direction. A light bulb is literally a wire that's terrible at being a wire, and that failure is glorious. This leads somewhere profound. We think of electricity as modern, a human invention, the dominion of engineers and power grids. It's not. Electricity is ancient, primordial. All of chemistry is electricity. When atoms bond to form molecules, it's an intricate dance of electron sharing and exchange, governed entirely by that rule of attraction and repulsion. When wood burns, electrons are finding new, more stable partners, releasing energy in the process. When your neurons fire, it's a wave of electrical imbalance racing along a biological wire at hundreds of miles per hour. Life itself is a sustained electrical phenomenon. You are a walking, talking, thinking pattern of charge balance. We just call it biology. Now I need you to hold two contradictory thoughts simultaneously and feel the tension between them. First, the electrical force is unbelievably, incomprehensibly, absurdly strong. It's roughly 10 quintillion times stronger than gravity. That number means nothing to you. Your brain can't hold it. Let me translate it into something visceral. If you and the person sitting next to you each had just 1% more electrons and protons in your bodies, just a tiny 1% imbalance, the repulsive electrical force between you would be strong enough to lift the entire Earth. Not a car, not a building, the planet. Second, you feel none of this, not even a whisper. Why? Because in you, in me, in your desk, in the air between us, the positive and negative charges are balanced with such exquisite, near-perfect precision that these titanic forces cancel out almost completely. Almost. What's left? The faintest ghost of a residue. That ghost is gravity, the gentle force holding you to your chair. The everyday solidity of reality is a perfect, silent standoff between powers that could annihilate worlds. This balance is why the ancients only stumbled across two electrical curiosities, rubbed amber-attracting straw and lodestone-attracting iron. They were playing with the fundamental adhesive of the cosmos and had absolutely no idea. The balance was too perfect to notice. The forces were too precisely matched to reveal themselves. But now the plot thickens in the most beautiful way possible. Electricity has a twin, a secret partner, magnetism. They seem different, unrelated. One gives you shocks when you touch a doorknob. The other sticks notes to your fridge. But they're two faces of the same coin. When electrons flow through a wire, they create a circular magnetic field around it. Bring a compass near a live wire and watch the needle twitch. Confused, pulled by invisible forces. Coil that wire and the field intensifies. Wrap it around iron, and you've created an electromagnet. Magnetism you can turn on and off like a light switch. And the magic runs in reverse. Move a magnet near a stationary wire, and you create a flow of electrons in that wire. No battery. No chemical reaction. Motion itself becomes electricity. This is induction, and it's the principle behind every generator on Earth. At a power plant, whether driven by falling water, expanding steam, or turning wind, something spins a giant magnet inside a massive coil of wire. That spinning motion, through this intimate marriage between movement and charge, transforms into electrical current that travels across continents into your home. The kinetic energy of a distant river becomes the light by which you're reading these words right now. It's a sublime transformation. Energy changing costumes but never dying. This union of electricity and magnetism was codified by James Clerk Maxwell in the 1860s, and it yielded an even more stunning revelation. Maxwell's equations showed that a changing electric field creates a magnetic field, and a changing magnetic field creates an electric field. They can sustain each other, feeding off each other in a self-perpetuating dance. And this self-propagating disturbance can travel through completely empty space. When Maxwell calculated the speed of this disturbance, the answer was exactly the known speed of light. The conclusion was inescapable. Light itself is an electromagnetic wave. The warmth from a candle, the colors on your screen, the X-ray revealing a fractured bone, the radio waves carrying music to your car. All the same phenomenon, just oscillating at different frequencies, different rhythms. We live submerged in an electromagnetic ocean, seeing only the narrowest, most fragile band of its endless spectrum. Let this truth settle into your bones, because it changes everything. You have never touched anything, not once in your entire life. When your hand rests on a table, the electrons in the outermost atoms of your skin approach the electrons in the table's surface. Both are negatively charged. They repel. The force of that repulsion, acting across a vanishingly small gap of pure nothingness, is what you perceive as solid contact. Matter doesn't feel solid because atoms are hard little spheres. Matter feels solid because the electrical force fields surrounding atoms are movable objects when met with equal opposing force. You are held aloft above every surface you've ever touched by a continuous, flawless electrical argument between the electrons in your body and the electrons in everything else. You've been levitating your entire life. Even the awesome, terrible power of a nuclear explosion is, at its core, an electrical phenomenon. Inside a uranium nucleus, 92 protons are crammed together in impossible proximity. Their mutual electrical repulsion is colossal, barely held in check by the short-range strong nuclear force. When that nucleus is split, the lid is blown off. The resulting fragments, both positively charged, repel each other with the full pent-up electrical fury that was being restrained. The explosion, the shock wave, the fireball, it's ultimately a sudden, catastrophic victory of the electromagnetic force over the force that was containing it. So we've learned to describe this force with extraordinary precision. We can predict it, harness it, weave it into every aspect of modern civilization. We can say what it does with phenomenal accuracy, down to decimal places that would make your head spin. But here's where we come full circle, back to that piece of copper in your hand. The deepest question remains completely unanswered. What is charge? Why does this rule of attraction and repulsion exist at all? We don't know. We found a pattern, beautiful and powerful and all-encompassing, and we've given it names and equations. But the pattern itself, the reason it exists, that remains untouched. Feynman himself, one of the greatest physicists who ever lived, was refreshingly honest about this. Physics doesn't give us ultimate whys. It reveals profound hows. It shows us the patterns woven into nature's tapestry, but it can't tell us who wove them or why those patterns were chosen. Electricity is one of the most fundamental of those patterns. It's the pattern of attraction and repulsion that structures atoms, forges molecules, animates life, transmits energy, and creates the very sensation of solidity in our world. We've learned to read this pattern with incredible sophistication. We've built skyscrapers of knowledge on top of it. But the reason for its existence, the why beneath the how, remains a glorious, humbling mystery. The universe is under no obligation to make sense to us. It doesn't owe us explanations. Yet here we are, conscious arrangement of atoms that have somehow deciphered enough of this silent, electrifying ride to illuminate our nights, power our machines, and transmit our thoughts across the world at the speed of light. We've learned to speak electricity's language, even though we don't know why that language exists. And perhaps that's the most profound insight of all. The mystery isn't a failure. It's not a gap we failed to fill. It's an invitation. A reminder that no matter how much we learn, no matter how deeply we probe, there will always be another layer, another question, another frontier. The mystery of charge, of why like repels like and opposites attract, stands as a monument to the limits of human knowledge and the infinite depth of reality. So the next time you flip a light switch, charge your phone, or feel the static shock from a doorknob, remember, you're touching one of the universe's deepest secrets, a secret we've learned to use but never truly understand. And maybe that's exactly how it should be. Maybe the questions we can't answer are just as important as the ones we can. Maybe they're the ones that keep us curious, keep us searching, keep us humble in the face of a cosmos far stranger and more wonderful than we ever imagined. That's the real power of electricity. Not just the light it brings to our darkness, but the darkness it reveals in our light.